Alright guys, hope everybody's doing okay. What we're going to do today is take a look at something called the factor label method. So maybe you've heard of this before, but if you look at this problem on the screen here, we could easily solve something like this using the factor label method. So sometimes I'll ask my classes to solve a problem like this when I introduce this topic and see what we can do. So you can give it a try if you want to. So after homecoming, you decide to throw a pizza party for you and 15 of your friends. You figure each person, including yourself, will eat 4 slices of pizza. You call up the pizza place and learn that each pizza is $14.78 and will be cut into 8 slices. So how many pizzas do you have, or do you have to order, and how much will it cost per person to pay for them? So you might have a couple different ways of approaching this, but one way to do it is through something called the factor label method. So we'll revisit this at the end of the lesson here and see if we could actually figure it out. So what is the factor label method? It's just a problem-solving strategy used to convert one unit or set of units into another unit or set of units. So it's a really important skill needed for success in this class, and you'll need your metric system equivalences, your metric system prefixes and what they stand for, and you'll have to memorize some of those. Okay, this is a skill that we learn now, and we literally use it throughout the entire course. So the sooner we get the whole strategy for factor label method under control and know how to use it, the easier everything becomes. And you could literally solve so many problems just by factor labeling and using this process. So let's take a look at some of the metric prefixes. And this is from your note sheet. Okay. There are only some of them you have to memorize. So the ones with the triangle are the equivalences you need to memorize. So how you read this is you have a base unit here in the middle. Okay. A base unit is just some unit of measurement, like a meter, a gram, a second, a liter, etc. Anytime you add a prefix, so pre means before, if you add a prefix to that base unit, so if you take a meter and turn it into a kilometer, that prefix acts like a multiplier of that base unit. Okay, so a kilometer is 1,000 times your base unit. Okay, so 1,000 meters is a kilometer. Okay, a mega, like a megasecond. Okay, a megasecond is 1,000,000 seconds. Okay, so I'm sure we're semi-familiar with the metric system. The ones underneath make your base unit smaller. Okay, the ones up top here make your base unit larger. So if you have a centimeter, we're familiar with that. If you have a centimeter, it's less than 1 meter. By how much? A centimeter is 1/100th of a meter. Okay, so you could say 1 centimeter is 1/100th of a meter, or you could, a little bit easier. You can say 1 meter is 100 centimeters. That's how I like to look at my equivalences. I like to work in terms of nice whole numbers. Okay, so I try to stay away from using the fractions if at all possible. All right. So the ones you have to memorize are with a triangle next to it. Any of the other ones I would give you. And if there is a situation where you have an English unit of measurement like a tablespoon, and you want to go into something metric like a milliliter or a liter, I would have to give you some more information. Okay? So when you factor in math, really, what is that? It's just simplifying, right? It simplifies things. So 5 divided by 5, if I give you 5 over 5, you'd tell me that simplifies to 1. Okay? X over x is really the same thing. X is just a number, right? But it's a variable here. X over x is 1. And then x cubed over x squared. If you have x cubed over x squared, the x squared cancels out. That 2 goes to a 0. And the 3 goes down to a 1. Okay? Anything to the 0th power is 1. So you end up with x to the first over 1, which is simply x to the first, or just x, right? So we're going to use this concept here of simplifying to work through our factor label problems. Okay? It all boils down to this, guys. Factor labeling is just canceling out the units you don't want and converting to the units that you do want. All right? Now I know that some of you are going to say, I could just move the decimal place, I could do this in my head, I don't need to factor label it. And it's fine if you want to like check your work that way or something, but the requirement for this course is you have to show the factor labeling steps. Okay, there are times throughout the course where if you want to do things a different way, that still involves showing your work and going through the correct process. I let you do that. This is one time here where you must show your work the way I want you to, and you have to show your conversions as you go through the problem. Okay, so just keep that in mind as you're going through this. When you're writing the notes down and writing down these examples, you want to make sure you're doing them, on your note sheet and then in your homework, just like I am. So let's go through them. So example number 1, I'm just making some problems up here. I want you to convert 45.6 centimeters into meters. You're going to say, oh, I can do that in my head in 2 seconds. Fine. You still need to show all your work for it. Okay, so step number 1 for any factor label method problem is you just want to write down what your given information is. So our given information is 45.6 centimeters. Now I could put that, like notice the fraction bars here. You don't need to put that there, but sometimes it's nice to put it there and put a 1 underneath so you can see it's 45.6 centimeters over 1. Okay, I want to get rid of centimeters. I want to convert that into meters. So if I go back, a couple slides here, I want to factor out the centimeters. I want to cancel it out. Okay, so if I do go back a second, if I wanted to cancel out x, well, I could divide it by x, and it cancels out, right? X over x is 1. 5 over 5 is 1. So if I go back to my problem here, I want to cancel out centimeters. I need to divide by centimeters. So I'm going to set up a big chain of multiplication problems here with fractions. So I'm going to take 45.6 centimeters and multiply it by some conversion factor. Okay? Next step, whatever you want to cancel out, which is centimeters, is going to go on the opposite end of your fraction here. Okay? So centimeters here, like what do I mean by that? Centimeters is on the top here. I want to put it on the bottom then here, so it cancels out. Okay? So I'm going to put centimeters on the bottom. I'm going to leave my number part blank for a second. I couldn't put centimeters up top, right? That wouldn't make any sense because you do centimeters times centimeters and get centimeters squared. So you don't want to do that. It makes sense to put it on the bottom. Okay? So what's going to go on top then? What you want to convert to. So I could easily look at my conversion paper and I have my base unit, which is meters. Okay, meters, base unit of meters. And then centimeters is here. So I'm comparing those two things. So I can easily do this in one step. I want to convert right into meters on top. Anytime you have a base unit in your problem with no prefix, notice how there's no prefix on this, you can easily do that part of the problem in one step. Okay, so notice what happens here. Centimeters cancels out. Okay, centimeters is up top, and it's here on the bottom. So what unit are we left with? We're left with meters. Okay, that's good. So now what do I want to do? I want to put numbers in here, right? So the numbers I'm going to put in there are based on this chart that you guys have, that metric prefix chart. So in 1 meter, remember I like working in whole numbers, you have 100 centimeters because a centimeter is 1/100th of a meter. So if you have 100 of them, that's 1 meter. 1 meter, 100 centimeters. Okay? If your prefix is underneath the base unit, then the base unit will be 1, and then whatever's underneath will be how many you need to reach that base unit. If you have a prefix from the top, then you have, X number of base units in one of those. So if you had kilometer, you would have 1 kilometer is 1,000 base units, 1,000 meters. Okay? So 45.6 times 1, don't really need to do that, divided by 100 gives you your answer of 0.456 meters. Okay, notice how meters is our final unit. We don't count equivalences for sig figs. Okay, so 45.6 has 3 sig figs in it. So you need to make sure your final answer has 3 sig figs, and it does. Okay, students always use an equivalence, and they're like, oh, that's 1 sig fig, so they round this to 0.5. Don't do that. Okay, you want to make sure you don't use equivalences in like with your sig figs, because they are exact equivalences. They're exact numbers here. There's exactly 1 meter in 100 centimeters. Okay, so you wouldn't count that. So it's not really a rounded measurement at all. Okay, example 2. 350 kilograms to milligrams. Okay, so we have 2 prefixes this time, kilo and milli. Last example, we had 1 prefix. We had centi, and then we had our base unit. All right, so let's take a look at it. Same steps as before. Let's start with our given information, 350 kilograms. Okay. Now, what are we going to do? I want to cancel out kilograms, right? So I'm going to set up a couple fraction bars here. I know it's going to be 2 steps. A little shortcut for you. If you see 2 prefixes, 1, 2, right, kilo and milli, you'll do this in 2 steps. Okay. You can do it in 1. It's a little bit more confusing. I like to do it in 2 steps. So let's find everything on our chart. We have kilograms right here. That's what we're starting in. We have milligrams down here. Okay. So kilo's big, right? And milli is small. So in 1 kilogram, there's a boatload of milligrams, right? I really don't feel like figuring out how many milligrams are in a kilogram. Okay. I can't use what's here. I can't use 1,000. Because there's 1,000 milligrams in a gram, and there's 1,000 grams in a kilogram. So I'm not going to bother with that. So key thing you should do here, if you have 2 prefixes, what I would do is convert to your base unit first. Your base unit is just grams. Okay? So you have 350 kilograms. I want to cancel out kilograms, so it goes on the bottom. Right? Kilograms cancels out. Instead of going to milligrams on top, I'm going to go to grams first. It's just easier that way. I've been teaching it that way forever. And students, if they listen to that advice, the silly mistakes are greatly minimized. Okay, so just trust me on that. Let's go to grams. I'll fill my numbers in later. Now, I'm not done because I want to cancel out grams. So I'm just going to do another step. I'm going to multiply by another fraction, by another equivalence or conversion factor. I'm going to cancel out grams. So we're going to put that on the bottom. Grams cancels out. And I want to go to milligrams. It goes on top. Okay? So now look what we're doing. We're going from kilograms into grams. Okay? And then grams into milligrams. Okay, so we have 1, 2 steps. All right? So step 1, what's bigger, kilogram or a gram? Well, kilo is above the base unit. So that's much bigger. So 1 kilogram is 1,000 grams. Okay? And then look at your other conversion. What's bigger, a milligram or a gram? Well, milli makes the gram smaller. So that means a gram is bigger than a milligram, right? So 1 gram is how many milligrams? Well, a milligram is 1,000th of a gram. So that means if I have 1,000 of them, it would be a gram. So 1,000 here. All right. Okay, easy. So you have kilograms cancel, grams cancel. You have 350 times 1,000 times 1,000. There's only 2 sig figs here. The 0 is not significant. So you get 3.5 times 10 to the 8th. Now you could have that whole number written out, but when you get so big, try to put it in scientific notation. Okay? That's example number 2. Other notes for you to jot down here before we do our last 2. You need to have these memorized. In 1 liter, there's 1,000 centimeters cubed. Okay? So a liter is what we, a liter or milliliter is what we use for volume. But if you're finding the volume of a cube, you do length times width times height. So centimeters times centimeters times centimeters gives you centimeters cubed. It's good to have a conversion between the two. All right? Additionally, there's 1 centimeter cubed in 1 milliliter. Okay? So we can use centimeters cubed when we're finding the volume of a cube, right? And you have to do length, width, and height. But usually we're going to use probably water displacement with a graduated cylinder, where we would measure in milliliters. So it's nice to convert between the two of them, and it's a good thing to know that conversion. So this is one that you want to make sure you have memorized. Okay? Okay, so example number 3. Convert 25 milliliters into meters cubed. All right, this is probably the toughest one we'll do. So let's start with 25.0 milliliters. I'll go through some of the steps a little bit quicker here. I want to cancel that out, okay? Notice how meters cubed isn't really on here, right? And you have liters here and obviously milliliters here. But how do you get from a milliliter, which is volume, into meter is length, right? But a meter cubed is also volume because it's length times width times height. So you're still converting volume into volume, which is you're allowed to do. You couldn't convert milliliters into meters or milliliters into meters squared, which is area. You have to convert a volume into a volume. Okay? So what can we convert milliliters into first? Well, I gave you these conversions here in this part of the presentation for this reason. You can convert milliliters into centimeters cubed. And then you know how many centimeters are in a meter. We can go through it that way. Okay? So I want to cancel out milliliters. And I'm going to go into centimeters cubed. Okay? So milliliters cancels. Now the thing is, with this, I have centimeters cubed. And this is a huge mistake students make. They do this. They go to the next step. And they say, I want to cancel out centimeters. So they put centimeters on the bottom. I want to convert into meters. They put meters up top. And then they're done. Okay, they fill their numbers in and answer it. And that's not what you want to do. Because if you have this conversion, look, you have centimeters cubed over centimeters. That's doing this. Centimeters cubed, ignore the horrible handwriting, over centimeters. That's really like centimeters to the first, right? Well, what does that simplify into? Well, the 1 goes down to a 0, and the 3 goes down to a 2. So just taking centimeters cubed divided by centimeters really just gives you centimeters squared. Okay? So what do I need to do then? Because this went down to a 2 now. Okay? And it canceled with that. All right? But I still need to cancel out the other 2 centimeters here. Okay? So no big deal. Just add another step and do the same thing. Cancel out centimeters and convert to meters. All right? So now we're down to centimeters to the first, and that cancels out. These are really centimeters to the 0. Okay? Which is just 1. Do it again. Cancel out centimeters. Now we're fully canceled out. Right? Fully canceled out. And go to meters. You wanted meters cubed. Well, look, you couldn't just have 1 meter, like the meters on the top here, and that's it. Because what you would be left with is meters to the first. Meters times meters times meters is meters cubed. Okay? So we're going to get the units that we want here. Notice how everything cancels out. We have meters, meters, meters. We're good to go. Let's fill everything in. We know that there was 1 centimeter cubed and 1 milliliter. That was the previous slide. We're going to compare centimeters and meters right here. Centi makes it smaller, so a meter is larger, and there are 100 centimeters in a meter. So you do that 3 times. Oops. Okay, you have 25.0 with 3 sig figs. Divide it by, well, nothing here. Divide by 100, divided by 100, divided by 100, and you get 2.5. Should be 2.50. Okay, sorry about that. 2.50, because that's 3 sig figs. So you want 3 sig figs in your answer. 2.50 times 10 to the -5th meters cubed. All right? That takes care of that one. 1 left to go. Students always get confused by this last one. Don't be. Convert 45 decigrams per liter into centigrams per milliliter. You're like, what on earth? No big deal. Follow your rules. You're good to go. So let's write it out. First of all, I like to do it this way. 45 decigrams over 1 liter. Okay? This is division. I mean, I know you recognize that. If you rewrite it like this, you can clearly see what's on the bottom. You can clearly see what's on the top. Okay? Students, I cannot tell you, just trust me. Students make so many mistakes writing it this way because it looks like everything's on the top here, and it's not. Okay? It's 45 decigrams over 1 liter. So, what do I want to do? I want to cancel out decigrams and convert it into centigrams. Okay? I want to cancel out liters and go into milliliters. Pick one and then do the other one. All right? So let's set up some fraction bars here. And I think I have us converting decigrams first. Okay, I do. So I want to convert decigrams into centigrams. So I have to go from decigrams to centigrams. Now again, this can be a little confusing. Notice how many prefixes. 1, 2. Deci is one prefix. Centi is my second prefix. Okay? I should do this in 2 steps. I don't want to figure out how many centigrams are in a decigram, even though it's not that hard. I'm just not going to deal with it. Okay, so I'm going to go from decigrams into grams, because that's easy. And then grams into centigrams, because that's easy. Okay? It might take the same amount of time as just doing it in 1 step, going from deci to centi, but I know the way I'm going to do it. I'm not going to make a dumb mistake. Okay? So I want to convert decigrams into grams first. So whatever you want to cancel goes on the opposite side, and whatever you want to convert to goes in the other spot of your fraction. I want to cancel out grams, put it on the bottom, and go to centigrams. Okay? So now look, the unit I want on top, what do I want this to look like? I want this to look like this. Centigrams per milliliter. Okay? So centigrams is on top. That's good. Now I have another step left. I have liters on the bottom. How do I fix that? No big deal. Follow your factor label rules. You want to cancel it out. You're not going to put it on the bottom, because when you multiply it all through, if it was on the bottom, you'd have liters times liters and get liters squared. Okay, so you don't want to do that. What you want to do is just cancel out liters on the top. Okay, so if liters is on the bottom and here it's on the top, if you multiplied all that through, you're going to end up with liters from the top divided by liters on the bottom, and they cancel. All right. So again, factor labeling isn't always putting what you want to cancel on the bottom and what you want to convert to on the top. It's putting what you want to cancel on the opposite end of where it is, and then putting the other unit in the remaining spot. So liters on top, and I want to convert it into milliliters. I want milliliters on the bottom, right? And I have no other choice but to put it there. So look what I have left. Centigrams divided by milliliters, which is exactly what I want. Let's fill in our conversions. A decigram is small, so how many decigrams in a gram? 10. A gram is bigger than a centigram. 100 centigrams in a gram. Okay? So that's straightforward stuff. Okay, remember these underneath the base unit make the base unit smaller. So there's 10 decigrams in a gram, 100 centimeters in a meter, 1,000 milliliters in a liter. Okay? And now, I just said that one. So 1 liter is 1,000 milliliters. 45 divided by 10 times 100 divided by 1,000. 0.45, 2 sig figs, 0.45 centigrams per milliliter. Okay? So, I think that all works out. 10. Yeah, looks good. Okay? So that's how you do it. It's factor labeling. None of the other practice problems you're going to have stray too much from what we're doing here. Okay? So I went through 4 examples from the easiest all the way up through like a double unit where we have this is really a density right here, which is a mass over volume. And we did a little bit of, we did a cubic meter on example 3. So I covered a lot of stuff here in this 25 minutes so far. What you'll do is work on some practice problems, and we'll talk more about some in class when we review, but this gives you a good overview of how the factor label method works. You can always revisit this if you get stuck and watch different parts of it over to see how things work and how they go. So, if you want to, if you're an Edpuzzle watching this, I might have you try to solve this. See if you can use the factor label method to figure out this homecoming ridiculous problem. I have a few other crazy problems like this I come up with in class. One might even be a bonus question on your test that's coming up. But it's interesting to see if you can use factor label method to figure that out. Okay, so give it a try. Type your answer in, see what we get, and we'll talk about this in class if you have any issues. All right, thanks guys.